What is up guys, I'm Fabio and on this channel I help you become a better programmer, so subscribe if you're interested. I'm sure you've heard about shallow copies and deep copies, or maybe you thought that a copy is always a copy, right? A complete copy of the whole thing. Unfortunately, that is not always the case, and in this video we're going to go deeper into this topic, and by the end you'll know everything you need to know. By the way, you can support this channel and also get the source code of my videos using the link down in the description. I really appreciate all of you who've supported me so far. So first of all, you need to understand that a list is not a list of actual objects, but is a list of references to these objects, okay? Basically, the memory address where you can find that specific object. So if you have a list like, I don't know, something like my list containing number 1, 2, string, then 4, for example, the first element will be, let's say, the memory address of the number 1, then the memory address of the number 2, the string hello, 4, etc, etc, etc. You can think of a list as a box containing pieces of paper with addresses written on them of the places where you can find the various objects, okay? So the box doesn't contain the actual objects, but just a reference of the place where you can find it. In this case, the memory address, and this is crucial to know, so I hope that makes sense. Okay, so let's try to create a copy of the list above. So in this case, let's actually call it my list copy. And you can create a copy just by doing this. Or another way of doing it is this. Okay, so these are the same thing. So let's actually stick with this version. So now we have two different lists, so my list and my list copy, that contain a reference to the number 1, then to the number 2, etc, etc. And even though they reference the same exact object in memory, that's not a problem because they are immutable, okay? So basically you can modify the 1, okay? You can modify the 2, the string hello, etc. They are immutable, and I've actually created a video about this, so go and check that out. I'll leave the link in the description, which is pretty interesting. But you can't just get this element here and change the E and make it an I like this. You can't do that. You need to replace the whole object. So as I said, that's not a problem even if you have two lists containing references to the same object. That's not a problem because you can modify it. Let's actually visualize that to make it a little bit easier to understand. So as I said, a list is basically just a list of memory addresses. So let's do something like this. So my list is sort of something like this number here, and then number here, and then another number here, like that, and then another number, like that, okay? So these are the memory addresses of these elements here, and the copy has the same thing. So you can just do something like this. Let's copy this and place it here. Okay, so now you've got, as you can see, sort of, let's say, two boxes. So you've got one box and another box. Inside the box, you've got 4 pieces of paper with address. This address, this address, this address, and this address. You've got another box with the same addresses, as you can see. So if you get the first piece of paper from my list and you go there, you find the 1. And the same thing applies to this, okay? So since these are all immutable, as I said, I can only replace them, okay? So let's say that I want to replace the 1 with a 9, okay? Using my list. So my list, the first element, which is 0, because a list is 0 indexed, and I do something like this. So by doing this, I've changed the memory address of the first value of the first list, okay? I've changed this value here. But the copy is not affected. So you've got something like this now. You get this, you go down here, and now you've got another address like that, but the second list still has the same address here. So as you can see, everything is fine, okay? You got my list, you've changed the number, and the copy of the list is still the same as before, okay? So that's fine. Let's actually print the lists to make sure that I'm not fooling you. All right, so my list copy like that. Let's do something like this. So Python, and then I'm gonna run the script like that. As you can see, I wasn't fooling you, right? 9, 1. All right, perfect. So The problem arises when you have a list of mutable objects. Let's actually delete all of that, like this, and let's pretend that we've got a list of lists. So you know that a list is a mutable object because you can actually change the elements inside. So as you can see, let's actually like that, we've got a list of lists, one list and the second list. So lists are mutable, as I said. In this case, though, I've got just a reference pointing to these lists in memory. Okay, so I don't have the actual list inside this list. I've got a reference to this list in memory, another reference to this list in memory, and so on and so forth. So let's do the same thing here that we've done earlier. So my list, like that. Of course, these are numbers that I've just made up, right? These are not actual number. I will show you how to see the actual IDs. But now we've got something like this. So basically, when you do something like my list 0, it's like you were actually saying to Python, go to address number 36, whatever, this number here, and then that you're gonna find a list 1, 2. And the same thing applies to this. Go to address number this, and that you will find 3 and 4. Okay, so let's now make a copy of it, as we've done it before. My list copy. Let's do this. Okay, perfect. So now we've got another list containing the same references. So let's copy this and do something like this. Perfect. So as you can see, you've got two lists, two boxes containing the addresses where this list can be found. So basically this list is now sort of shared between two lists. I've actually created a little visualization of the whole thing to make things even clearer. So let's do this. All right, so if you access my list 0, it's like you were saying to Python, go to this address and you find this. The same thing in my list copy. Okay, my list copy 0, go to this address, which is the same as you can see, and both lead to the same list in memory. Okay, so this list is shared. Let's actually, as I said, see the actual IDs. Okay, so to see the actual IDs, instead of just these things that I've just made up, let's do something like print ID my list and then my list copy, like that. In this case, you're gonna see different IDs. As you can see, they are different because these are different lists. But ID and then my list 0, okay, and the same thing applies to my list copy, like this. All right, let's go back here. As you can see, this in this case, as you can see, the same ID. Okay, so let's pretend that here I actually wrote this like that, something like that. Of course, this changes when I run it the second time, it changes, but this is just to show you what I mean. So let's go back to that. Perfect. So what does this mean? This means that if you were to change the content of this shared list, the change would be reflected in both lists, or even 3 lists, 4 lists, etc. So if you had 10 copies, that would be the same. You would have 10 lists, 0 pointing to the same object in memory. All right, let's actually comment this out like that. So let's actually try to do that. Let's change the first element of the first list. Okay, so basically we're changing this thing here. The first element is this one, and we're gonna set it to 10. Okay, so here we're basically saying something like this. Let's copy that and go down here. Perfect. So here we're saying get the first element of the first list, which is this one. So the first list is this address here, and change the first element, which is this one. So now this one is going to be 10. So even though I've actually changed the element using my list and not my list copy, but when I want to actually access the first element of the my list copy, I'm going to use the same address and I will find the 10 too. Okay, even though I've changed it using the my list and not my list copy. I hope that makes sense. So if I print my list copy now, as you can see, 10, 2. Okay, why? Because this is the same object. I've changed it using the my list, but the change is sort of reflected because you're actually accessing the same object. Okay, so this is basically a shallow copy, okay, meaning you're just copying the references to these objects in the list, and you might end up with problems down the road, of course. A deep copy, on the other hand, is a copy where you're not copying just the references, you are basically creating new objects, okay, lists in this case. By the way, before I show you what a deep copy is and how to actually make them, I just want to remind you that you can support the channel and get the source code of my videos using the link down in the description. Let's actually keep this thing here, but I'm just going to remove all of that, like that. So let's say that you have a list containing another list. Okay, in this case, I'm not gonna create two lists inside, but that is the same thing as before. Okay, so 1, 2, but you could have other lists here, but let's just keep it simple. Let's say that the address of this list, let's actually comment that. Okay, so let's say that this is the address, and that leads to 1, 2. Okay, so basically, as I said before, the list doesn't contain the actual list, but just an address that leads to this list in memory. And now let's say that you make a deep copy. Okay, I'll show you how in a second. So the list contained in the copy will be a completely different list, still containing 1 and 2, but in a different location in memory. So the copy is going to be something like copy. Inside here, you're gonna have a completely different address, and then still 1, 2. So in this case, you have two completely different objects. So let's actually create the little visualization that I created, show you that. So in this case, as you can see, you've got the two lists, but inside you don't have like this the same address. So same address leading to the same object in memory. You've got two separate objects. So this object here leading to 1, 2 is one object, and this is another object. Okay, so two different objects. So if you were to change one list, the other wouldn't be affected. So if you were to do something like, I don't know, my list 0, 0, then 0, 10, right? Now you would end up with something like this. So you would end up with 10, and this wouldn't be affected at all, right? Because you are actually changing this object here, but not this object. So how can we actually make a deep copy? So to do that, we need to import the copy module. Okay, so I'm just gonna do that here, but of course you should import everything here. But in this case, it doesn't matter. Okay, so let's use the same lists. So I'm just gonna keep the here, like that, like that. All right, so let's use this down here. Okay, and let's actually make a deep copy. My list copy. And in this case, I'm going to use the copy module. Deep copy, my list, like that. And now, if I print the IDs of the my list and the my list copy, of course, these are different, and they were different even before, right? As you can see, they are different. But if I were to print the first element 0 and the first element here, which is this one, which is this list here, earlier, if you remember, these were the same exact ID. But in this case, let's see. As you can see, you've got two different IDs, which means that this list here is a completely different list, a completely different object than the one in the copy. And in fact, we can actually do this to prove it even more. So we could do something like my list. Remember that we did that. And let's do print my list 0 and also my list copy 0. Let's actually comment that out. All right. So we are basically creating a list, creating a deep copy of it. Then we are changing the first element here of the my list, and the deep copy shouldn't be affected. Let's see if that's the case. As you can see, 10, 2, 1, 2. This is a really important concept to know, because you might end up with errors and things because you thought that maybe you created a copy of the list, but you actually didn't, and so on and so forth. So if you're still watching, you can support the channel and get the source code of my videos using the link down in the description. Like the video if you liked it, and subscribe to the channel as well, and I'll see you in the next one. Bye.